this video, we'll walk you through an example of a binomial distribution problem solved in Excel. So here we're looking at information about applications to a management trainee pool and how many are actually accepted. Distribution formula. We type in binomdist to the oldest formula that we have on there that had that caution sign. That's fine. I'm selecting that because that will work on all versions of Excel, even if you have an older version or if you're using a Mac and it may not have been updated. So it's going to ask me for a couple of pieces of information. Number S, that's the number of successes that I'm looking for. So I want to know what is the probability that 3 are accepted. So if I define a success as being accepted, I want to know the probability that 3 of them are accepted. So that's my first number that I stick in. Well, I selected a random sample of 20. So the number of trials, the number of potential acceptances is 20. Then probability of S, that's 14% probability of getting accepted, comma, false. So the probability 0.09%. So the probability that any 3 out of 20 randomly selected applicants will be selected is 24.09%. Now it's asking me, what is the probability that at least 3 will be accepted? So I'm going to create a table in order to answer this. Okay, and then probability. So 4. Well, I don't know how many applicants there are in total. I know that I selected a random sample of 20, but I don't know whether 20 was the entire applicant pool or what we're looking at here. So the way I'm going to solve this, I'm going to figure out the probability that 0 are accepted, the probability that 1 are accepted, 2, and 3. And then I'm going to subtract off that, subtract 1 minus this probability, because these are going to give me the probabilities that less than 4 were accepted. So the probability that at least 4 were accepted. So I'll just create probability. So is greater than 4. So at least 4 of them are accepted is equal to 1 minus the sum of these probabilities. So minus this, and so on and so forth. Or I could just add them up and, say subtract that. So 30.14%. Now note that's the same as saying 1 minus this. It's going to give me that same number, however you want to do it. So one of the ways people remember is with at least. If you want to remember that calculation, you can either use the sum and do 1 minus that sum, as you see here, or you can individually subtract them off, and that kind of tends to help people look at that. Now the next question, what is the probability that less than 6 will be accepted? Okay, so I can just kind of continue this down, and if I highlight there and drag down, I can come up with 0, 1, 2, 3, 4, and 5. So it doesn't say 6 or less, it says less than 6. So that would be the probability that 0 through 5 people were accepted. And let me just continue down this formula right there. So the probability that less than 6 people would be accepted would be the sum of all of these probabilities. So literally, probabilities that less than 6 were accepted. So that would be 93%. The other things that it's asking in here, so this binomdist formula that we just used is an application of that algebraic formula you have there. Other things that it can ask you, what are the E of X, what's the expected number of applicants that would be accepted? So E of X is going to be equal to, and this one is, pretty simple to look at, just following that formula, is equal to 20, which is the number of trials that we have in there, times that proportion that we're looking at of 14%. So on average, roughly 2.8% of those people would be expected to be selected. The variance, again, using that formula that I have there. So the number, is equal to, and I'm just literally applying that formula,